Okay, let me just explain you about. So here I have imported all the necessary libraries, NumPy, Matplotlib, and the pandas, and I have read through the CSV file or the data set, and then we are trying to retrieve the stuff whatever that we require. Okay, if you can take a look at this one, I have taken only the age and the estimated salary. Okay, and at the same time I have taken the y referred values, which are the purchased values. Okay, so y is the target variable and x is the set of predictors that we do have. Over that, I have used the train test split function from the scikit-learn library of the cross validation, and I have split the data across. Now, in order to do the feature scaling in Python, we have something called the standard scalar. We have to import that standard scalar from the package called pre-processing within the scikit-learn. Okay, so then once you import that part, you need to just say, you need to create the function, okay, and sc dot fit underscore transform of train. Fit underscore transform means you're transforming the regular data into a scaling data. Okay, if you can understand the way that how it was transformed, x underscore train. See, the entire data picture has been changed, right? This is not the regular values that what we do have. Now you understood, right? The kind of scaling, how it is going to be. See, the quantity or the the one which we have discussed yesterday. Okay, it was got decreased, and now I'm just importing the logistic regression algorithm where I'm trying to provide this one by fitting the X train and Y train. I'm done with that. I'm also predicting the values for the test set, and I can make the confusion matrix. Yes, it is suggested to do the scaling before you do this kind of stuff within the classification parts, Ram Dinesh. Otherwise what happens if you are not going to use the scaling? You know, if I ask you 2 into 4, you can immediately tell me 8. If I ask you double 2 into double 4, is it taking the processing time for you or not? So in order to make it lesser, the processing time, we need to implement this kind of scaling, which could give us some sort of flexibility. Before we are thriving that particular data into the model is not is nothing but an algorithm in the background, a formula, a typical formula. Okay, so we should not make more burden out of it in order to calculate and give us some result. So I just made the confusion matrix. This is the confusion matrix which is done. If you want to verify the recall and the precision and all kind of stuff, you can always go ahead with the diagonal stuff. Okay, and by all these kind of precisions that we have already yesterday calculated, you can also calculate by getting the how much good this particular uh, algorithm is doing and all stuff. So now you can see this visualization by using the matplotlib. Okay, and we have used the listed color map in order to arrange the mesh grid. So this is the one. The classification, all the zeros, the people don't buy. Okay, and the all ones, the people who buy. From the segregation, this is a training data set what we do have. Now based upon the same model, we are trying to evaluate the test data set. Okay, so this is the test data set, which is a 25% of what we have the data with us. All of you understand this part? Yeah, guys, see, I'm explaining you all this code, but while you are doing the practice, you have to type all this code by your hands on. And also, let me tell you one thing: when you are visualizing the training results or the test results, you have to go one by one. Why we are using these things? Why? Because this is a one-time stuff, guys. So why? Because see, this plt.title, this is all simple issues actually. Title, label, legend, show. This is a small thing, and the main thing is what you are giving it as x1 and x2, and how you are segregating your training data. The predictors are there, and at the same time, the target is there, and how you are importing the respective required kind of stuff like listed color mac or some other things from the matplotlib.colors. You could find these kind of visualization libraries lot and a lot online. Even you can go for the python documentation of the scikit-learn, or wherever you go with the matplotlib, it will suggest you a lot of stuff. You can make wonderful visualizations. Okay, but at the end of the day, first of all, we should understand the segregation, first of all, data segregation. Okay, so this mesh grid is none other than function that we need to arrange. We need to use it in order to arrange. Okay, so once you do this one once, this is not a repetitive task where you can use a copy and paste, and you can replace the values where you want it to replace. You want to improve the alpha value, you want to decrease the alpha value, otherwise you want to change the coordinates. Okay, you can do this by yourself based upon your requirement. But while you are doing it, go by step by step, and you would have a clear understanding about what you are doing with the visualizations. Understand? If you write one program by your hands on within the classification, then that is fine. See, look at the program and type each and every line by your own. And without looking at the program, type each and every line for another program within the classification itself. Then do think only one thing. You should have a meaning of why you are writing each and every of these lines. What if you are not going to use the contour F? What is missing in your visualization if you are not going to depict the contour F? See here in the contour F, this is the one where we are relying on for giving the x1 comma x2 representation, and at the same time, why? Because two predictors are there, right? Why we do have the x1 comma x2, guys? Huh? Hello. Why we do have the x1 comma x2? We have two predictors here, and we are trying to classifying it, okay, by passing it through an array, and we are trying to reshape the same kind of stuff by providing the valid cmap, okay, which is segregated by the red and green color. Okay, so even you can see that this is also an array. Okay, and here the x1 comma x2 represent the mesh grid. Okay, two arrangements using the numpy, right? Okay, guys. So this is what all about the logistic regression that we have discussed now. So now let us understand the KNN. KNN means K nearest neighbors. K represents the degree of the model. And here we are going to use the same example. Okay, but the only difference that you have to understand here, the standard scalar is same. The only thing is you are importing the K nearest neighbor classifier. Okay, and K nearest neighbors classifier, we are trying to use the same sort of predictions and all the confusion matrix. Okay, and also even if you can take a look at this particular visualization, you could see everything is in common. Okay, but the only thing is you need to change the titles and all stuff, and also not only the titles but also the model which you have used over there. What is the model that you have used? What is the model that you have created? Classifier, the variable name. You have to use a classifier over here, whatever the variable name that you have used over there. So now let me just drag through this one. So you could see the k nearest neighbors training data set. But using like this, let us go ahead with the confusion matrix. See, if you can see the confusion matrix 64 4 and 329. Is there any difference between these two things, guys? Did you understand the difference? So the confusion matrix, what you are using for the logistic regression model and the k nearest neighbors model could be different. So we know that based upon this confusion matrix, we can always try validating the particular model of the classification part. So through this one, you can clearly understand which model is going to be the right fit for you in order to go ahead. And then you can pick that model. K-nearest neighbors is a very popular model basically. Okay, in real time, we will use this one very frequently and regularly. And what you are asking, Narayana, how will we know -1 or +1? What about it? Okay, you are asking about this function. See, you can always try. This is all about what all that you are trying to access within the x1 and x2 predictor. Okay, you can, if you can try this one, you will get exactly. Let me show you within this mesh grid. So here, before that, I need to understand that we have used this part. Okay, now I just want this one. So these are all the different values that I'm trying to get it from the x underscore dot set values. Okay, I'm trying from the start. Why? Because these are all the scaled values, right? You can always try even that part. See, this x underscore train, comma y underscore train are the scaled values. Okay, through the scalar. Okay, what we are trying to do, see, but using the scalar, what we are trying to do is, let me show you. If I'm trying to use this part, take a look at this one. You see that 0, -1, the coordinates will change. Okay, in order to keep all the things in the coordinates, I need to regularize the data. I mean, not regularizing the data, I need to, keep all the things in the, one coordinate. Okay. So I am adjusting the data over here in order to arrange the entire stuff within the x underscore set. Okay. So I'm trying to arrange all this data, and I'm just making a grid of this data. Grid represents within a block, so that we can visualize the data in the same manner. Okay. So for example, this is the start one and this is the stop one. Okay. Now let us try understanding one more thing here. This is x1, right? So now what I'm trying to do, sum a1 equal to, just take out only this part. If you wanted to explore, not only for this program, if you wanted to explore these kind of, you will see some other projects online. Okay. Otherwise, whatever the projects that you are going across, even in your company, if they have written some code, some people will do the code, very complicated. Okay. So if you wanted to avoid that complication, you need to go step by step. You need to get something like this, so that you will understand what exactly this mean. So x underscore data set of, you can also try even this part. So x underscore set, we know what does that mean. That is nothing but a training data, right? I will show you that. Look. Okay, this is the training, means a scaled data as x underscore train. So now what I am trying to do, I'm trying to do this part. So I tried something like this, right? So what happened? A1, I have the transformed data over here, where I am trying to get the minimum with the minimum function. So now what I'm going to, I have got the minimum, and now what I'm going to do, I'm going to take -1. So this is the where the starter, which will be starting as a value. So the np dot arrange, what the arrange will do, arrange function will do, guys. All of you, it will start the number of data, I mean the data from there onwards until -1 represents a little bit before, +1 represents the ending of the data, plus means, for example, these are all the start and stop of the values which are there within the set of array of values within the training data sets, which are representing to the predictors. Okay. So if you just go ahead with the same stuff. Okay. Max represents, what the max represents here, guys? Max value, right around 2.16 is the max value. What I'm making, I'm just trying +1. See, Narayana, why we are giving -1 and +1, so that we should not come out of the, we should not give the edge to the values. If you understand, did you understand my point? If you make the -1 and +1, we will not give the edge to the points, and also arrange values will exclude, for example, if I'm going to say something like this, take a look at this one. Can you see that we are missing out the 6 at the end, right or wrong? Right or wrong? And also, do we require this 0 here? Right or wrong? So we don't want it to give the edge to the values. So that's why we have added the -1 and the +1 to the existing stuff. Okay. For example, now here, my arrange of values are -2 2.99 comma 3.166, for example. So those are the stuff. Okay. And here I'm just trying to make a step is equal to 0.01. Now let us take a look at this one, how well it is going ahead. It's going to give you a lot of stuff. Got it? All of you understand this part? Suresh? Yeah, this is all for our, flexibility. Nothing more than that. See, understanding this one is very easy. Even that we have gone through the Ravel and we have gone through the reshape. Did you remember? While we are working with the Python, we went through all these things. Okay. So please go through them and also transpose dot t. See, representing the data in a visualization format definitely requires a coding. So that coding format, for example, let me say, if you are going to be into a project and they require some sort of visualization, if they are using the Tableau and Power kind of stuff, you cannot generate this kind of stuff with them. Either you require to use the R script. Definitely there is this, you have to check that there is an integration with the R script for all these tools. Okay. But in Python, generally we don't, much rely on the visualizations. Basically, we always relying on machine learning with the results, some sort of results. Visualizations and all takes a secondary part. Of course, I'm not saying that it is not a big deal, but it is an important one, I could say. Okay, but the one-time coding that we have to understand this part, guys. See, you understood this part here, right? So if you can see, there are the different models of doing this kind of visualization techniques. Okay, if you can get some odd 5 models once you enter into a company, basically in all the companies they will use something, some sort of mesh grid. Definitely they have to use the mesh grid. Okay, so apart from this mesh grid, if there is any latest library that they are coming up or that they're trying to pick up, you can easily understand one-time process. Otherwise you can just delete their way of implementation and you can try new a new strategy of the new visualization technique, and you can show it up and you can make copy and paste and you can change the values. It's a one time process. Okay, you are not required to bother about this one much. Okay, why? Because this is a one time process. You need to understand how you're, see, first of all you need to analyze the data in a layman model, then you analyze the data in the programmatical model. Understand? Otherwise if you take a look at this one, it will looks like very weird programming structure, but which is not. This is not a weird programming structure, but all of a sudden when you look at that one you will be confused. You know what is mesh grid, you know what is arrange, you know what is Ravel, you know what is reshape. We need to club all these things together. That's it. Okay, so guys, this is what all the k nearest neighbors and the logistic regression that we have gone through with. So now we also require to go ahead with the decision trees and the random forest, where we will discuss that part in the tomorrow session. Okay, not the decision trees and this stuff. I think decision trees, and I have some other algorithm to discuss actually. Okay, I will discuss that part. Sure. Thank you.